Okay, so our next topic is vectors. And vectors are one of the most important constructs in all of physics. A vector, simply put, is a mathematical construct that consists of two pieces of information instead of just one. If you're talking about 5 meters or 20 seconds or 39 degrees, those things are just one piece of information. The units don't count as information. So a vector is something that consists of two pieces of information. The two pieces of information could be 5 meters that way or 39 degrees counterclockwise or something like that. Time actually only has one direction, so you can't turn time into a vector, but time could be one of the components of a vector. The components of a vector have to do with the two or more pieces of information that make up the vector. So let's take some examples. Things like 5 meters, 4 seconds, 39 degrees are examples of scalars. A scalar quantity is something that you already are familiar with, even if you've never actually heard the term before. So a vector, by contrast, is an example of a vector would be displacement. Displacement, an example of this, is 5 meters that way. Whereas a distance, if we're talking about distance and we just say 5 meters, that's just one piece of information. This is two pieces of information. Another example is speed. If I'm going 60 miles an hour on the freeway, that's just one piece of information. If I'm heading 60 miles an hour north on 280, that's two pieces of information. So what we would say is that vectors have a magnitude and a direction. A magnitude basically means how big, and direction just means north. But really, this is more specific, but in general, a vector is something that has two pieces of information to it, or two or more pieces of information. And by two or more pieces of information, let's just take this vector here. This vector represents the displacement if you start from here and wind up here. The two pieces of information could either be, I don't know, maybe this is 10 meters at an angle of 45 degrees, say. But another way we could write this is that you go a certain distance this way and a certain distance that way. I didn't draw that very well, but you get the idea. So this component is called AX. This component let's call A sub y. When you're talking about the vector, meaning this thing that has more than one piece of information to it, it takes an arrow over it. And when you write the components, they do not have arrows over them. That's how you tell that these are components and not the actual vectors themselves. So we would say that vector A, we could write it as this thing with two pieces of information in it, AX and AY. Okay. So if we define a set of coordinates like this, then your two pieces of information could be the magnitude and the direction. The magnitude, it would just be the length of this arrow, and the direction would be as measured from the x-axis. So for instance, you have to pick a direction here and say, okay, this angle is measured from here to here, so maybe that's 45 degrees or something. If you write A with no arrow above it, that's a shorthand for this. So this and just that are the same thing. I might start out in class using this, but after a while this gets kind of tedious and really messy. So this does not mean that I just forgot to put the arrow. You have to be really, really meticulous. If you just write this, I'm going to assume that you mean this, not that, oops, you forgot the arrow over it. Okay, let's continue. All right, adding vectors numerically is a way better method to add vectors together. The way it works is that you have two vectors and they each have x and y components to them. So for instance, this one, AX is going to equal something and AY is equal to something. And we can figure out those things using basic trigonometry, your definitions of sines and cosines. Now is a really good time to review all that material. Vector B has 0 x component, and the y component is just going to be equal to 3 meters, and it points in the negative y direction. So that would be negative 3 meters. So let's take a look at this more closely. So here is what the x component of A looks like. Here's what the y component of A looks like. And we know that theta is 55 degrees. This is given. The length of A, see, this is the A without the arrow over it. That means the magnitude of A. That means the length of this vector. So the length of this vector is 6 meters, and then we can figure out what the x and y components are. Remember, these guys are not vectors unto themselves. They point in particular directions. They might point in the positive x direction or in the negative x direction. Same thing here. It may point in the positive y direction or the negative y direction, such as this one points in the negative y direction. This is how you calculate exactly what the values of these are, just like in your previous math classes. And for this one, bx is equal to 0. If you put in the cosine, just follow the same formula here. Bx is equal to the length of b, so just the magnitude of b, 3 meters, times the cosine of 270. Put in 270 degrees into your calculator and you'll get 0. So by here is going to be equal to 3 meters, except it's negative 3 because it points in the negative direction. If you put in the sine of 270, it will give you negative 1. So this will follow the exact same formula as this thing here. Okay, so what we're going to do is to add these together. So what you do is once you find all the x components, you evaluate them, and you find all the y components, and you evaluate what those are using the equations on the previous slide, you add them up, and then that gives you the new x component for the resultant vector. So the c component of the resultant vector is going to be the sum of the x components of a and b, and likewise for the y component. So here's what it looks like. Graphically, here's your a from before, here's your b from before. Graphically, we know that c should point off in vaguely this direction. It should be at an angle of less than 55 degrees. It should be a positive angle. Everything is measured from the x-axis, going like if x along the x-axis is an angle of 0, and then we measure it around like this, counterclockwise from the x-axis. Just like in your math classes, there's nothing different about physics here. So then you add those up, and it should give you two components of c. So in other words, here's the x component of c, adds up to 3.44, and the y component adds up to 1.91. This definitely looks longer than this, and this definitely looks smaller than 55 degrees. Let's figure out what it is. Okay, so when you take the arctangent of cy over cx, because the tangent of theta equals opposite over adjacent, you get that the angle is equal to 29 degrees.